Assalamualaikum warahmatullahi wabarakatuh. We are from Group 8 and we will be presenting some slideshows about the electrical and magnetic principle in aircraft system. First of all, I will introduce our group members. So our first member is Nur Harif Izzat with metric number DD240078. Our second member, myself, Naina Fariza, with metric number DD240116. And our last member is Ali Afrina with the metric number DD240127. As for the introduction, I will explain about the electromagnetic systems in aircraft. So basically, in most modern aircraft, aircrafts rely on the electromagnetic principles to generate, manage, and distribute electrical power that is very essential for flights. So electromagnetic induction is basically described by the Faraday's law. Faraday's law, where the engine-driven alternator will convert the mechanical energy into electrical energy. So the examples of typical light aircraft electrical systems are a battery where it supplies DC power for engine starts, alternator that produce AC that will be rectified to DC for onboard systems, and the bus distribution network that is protected by the breakers and fuses.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wanur Ali Afrina binti Rosdi and my matrix number is DD240127. So for this slide, I will explain about the electrical principles. So as we know, electrical principles involve the fundamental concepts of voltage, current, resistance, and the power. So the first one is about the voltage. It is the electric pressure that pushes current through a circuit, it is similar to water pressure in a pipe. The next one is about the current. Refers to the flow of electric charges, which is the electrons, through a conductor, and it moves due to the applied voltage. The third one is about the resistance. Resistance is the opposition to current flow within a material. So the conductors like copper have low resistance, while the insulators have high resistance. So for overall, these three values are related by Ohm's law, which states V equal to IR. And then the aircraft electrical systems use both alternating current AC and also the direct current DC. So from the AC, it flows in alternating directions, and it is used for high power systems like galley equipment and or the cabin lighting. While the DC, the direct current, it flows in one direction, and it is used in avionics, sensors, and also the control circuits. So the last one, I will explain about the power. Power in an electrical system, it is calculated using the formula P equal to IV, which is representing the rate at which electrical energy is consumed or delivered. For the next slide, I will explain about the magnetic principles. So the magnetic principles are centered around magnetism and electromagnetic induction. The magnetism is a force generated by moving electric charges or magnetic materials. It is used in instruments like the magnetic compass. A key concept in aviation is electromagnetic induction, which is based on the Faraday's law, which states that a voltage is induced in a conductor when it moves through a magnetic field. So this principle is used in aircraft generators, which convert the mechanical motion from the engine into electrical energy. It also plays a role in navigation systems such as flux bulbs and magnetic compasses, which use Earth's magnetic field to help determine heading. And lastly, electromagnetic force is used in relays and contactors, which are switches that open or close electrical circuits using magnetism. These are vital for controlling high power system safely. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nohar Izzat bin Nur Azizi. The metric number DD240078. Now I will present about application in aircraft system. The first application is electromagnetic induction in power generation. The principle is Faraday's law, changing magnetic field induce current in conductors. Application in aircraft generator mounted on engine use rotating electromagnet to produce AC power. The impact efficiency is replace heavy battery as primary power source, reducing fuel consumption. For the safety, backup generator ram a turbine deploy during engine failure, powering critical system. For the reliability, brushes design minimize maintenance and spark noise. For example, is Boeing 787's variable frequency generator adjusts output to engine speed, optimize power efficiency. The second application is magnetic sensor for position detection. Principle: Hall effect magnetic field after current in semiconductors. Application in flap or slat position sensor detect wing surface deployment. For the impact safety, ensure wings are correctly configured for takeoff or landing. Faulty detection can cause crashes. For reliability, non-contact sensor resist wear from vibration or moisture. For example, Airbus A350 use Hall effect sensor to monitor landing gear position. Last but not least is magnetic shield for avionics. Principle: ferromagnetic material redirect magnetic field. For application shielding cockpit instruments from interference. Impact for safety is to prevent compass or autopilot errors caused by onboard EMI. For reliability, critical for navigation in poor visibility. For example, is 5335 avionics suits use metal shield to protect sensitive electronic.
To conclude, the modern aircraft are mostly rely on electromagnetic induction as described in Faraday's law, where a changing magnetic field produce electrical current to generate power. So when the power is generated, the power then will be managed using devices like transformers, inductors, solenoids, and relays that use magnetic field to regulate the voltage, filter out the electrical noise, and also acting as a control mechanisms. Additionally, the magnetic compasses and flux gauge instruments are used to provide the accurate heading information. So basically, to ensure the smooth, safe, and reliable operation on flights, all these systems have to work together properly.